Alright, today we are going to talk about how to solve systems of linear equations by graphing. So a system of linear equations, that's two or more equations with the same variable. So I'm basically going to give you two lines in Algebra 1. When you get up to Algebra 2 and beyond, you might have 3 lines or more lines. So a solution to a system of equations is the ordered pair that satisfies both equations. So satisfy means if you plug it in, it makes not one equation true, but actually both of the equations true. Another way of thinking of that is where they intersect. So it's the point of intersection of the two lines. So the point of intersection for the two lines. There are 3 ways to solve. You've got graphing, elimination, and substitution. Today we're just talking about graphing. You can use any of these 3 ways at any time, but usually graphing's best when one or more or both of them are in slope-intercept form. Elimination is usually best if both of them are in standard form, and substitution is usually best for those that are kind of in between, where one's in one form and one's in the other. So as long as you've got a variable to solve for, substitution is the best. You also have 3 possible answers you could get. If the lines intersect, then you get one solution. That's most of them. Then you've got 2 special solutions. One where there is no answer, meaning they don't intersect because they're parallel. Remember, parallel means they have the same slope. So you can usually tell before you start graphing if they're going to have an answer or not. And then the third possible solution is infinite solution. So if you have one line and then you have the exact same line, that's going to intersect a million billion times along that. So we call that the infinite solution. So when you are solving these by graphing, first make sure the lines are in slope-intercept form, and then graph the way we used to. So here we go. This is in slope-intercept form. That means it looks like y equals mx plus b. The b where you begin is the y-intercept. So my first line is at -4. So on my y-axis, I start at -4 right here. Put my first point. My slope is whatever's in front of the x here. That's 2 over 1. We want rise over run. So I want to go up 2 over 1. Up 2 over 1. I'm going to pause right there and leave that as is. I might need to extend it to see where it's going to hit the other line in a bit. I'm going to switch colors so that I can see how this other line meets up with it. So my new line starts at +8. It begins at 8. So 1, 2, 3, 4, 5, 6, 7, 8. Then it says -2 over 1, so it needs to go down 2 over 1. So down 2 over 1, down 2 over 1. I'm going to keep going until I hit my line. There it is. Let me just double check that one. Up 2 over 1, up 2 over 1, up 2 over 1 again. Good. So I have 2 lines and they are intersecting at this one spot. Let me bold that up for you. Here it is. And that solution is 3, 2. Remember, it's x and then y. So over 3 up 2. So the solution is 3, 2. Now if you're not sure if you graphed it exactly right and you're not sure if you lined it up perfectly, here's how you check it. You've got your equations up here. So you've got your y and you've got your x and you've got an x and a y right here. You just need to plug it in and check it. So I'm going to plug this y right there into that one. So 2 is equal to, maybe, if this is the right answer, 2 times x, so 2 times my x, which is 3, minus 4. Let's see if this is true. Is 2 equal to 6 minus 4? And that is 2, so we have the right answer. So that works for the first line, but this is a system, so it needs to work for both. So I've got to do a second check with the next one. So y is now my 2 again. Is that equal to -2 times my x, which is 3, plus the 8? So let's see, does 2 equal -6 plus 8? And that is also true. -6 plus 8 is 2. So when you check it, plug into both of them and make sure it makes both of them true. So for our next example, neither of these are in slope-intercept form, but you can still use graphing to solve it. So all we need to do is rearrange the equation to say y equals mx plus b. So right now this first one says -3y equals -9. I need to move this 1x over there. So it's a positive 1x. So I need to subtract it to the other side. So I'm going to rewrite it as -3y equals -1x minus 9. Remember, if you want to switch the side of a term, you switch the sign of the term. Next up, I don't want the -3, so I need to divide by it. But if I divide this, I need to divide everything by it. So what I really have here is y is equal to double negative cancels, 1/3 x plus 3. That's because 9 divided by 3 is still 3. So my first line, I'm going to start up at 3. I'm going to go up 1 over 3. That's my slope. Rise over run. Up 1 over 3. I'm going to switch colors and do the next one. So for this one, got my 1x, I've got my negative 1y, and I still need to get my 1x to the other side, so I'm going to subtract it. So I have negative 1y equals, now I negative 1x minus 1. Divide everything by that negative 1, or you can just go through and change all your signs. So y is equal to positive 1 over 1x plus 1. So again, that double negative thing is canceling out. So I'm going to start at 1. And I need to go up 1, over 1, up 1, over 1, up 1, over 1 until I hit my other line. And I saw it right there. Pick a good color. Right there. And that was at over 3, up 1, 2, 3, 4. So 3, 4. Now if you were going to check this one, do not check it after you have messed with the equation. So you don't want to mess with any of these. You want to go back to the original. Because if you made a mistake, it was probably when you were rearranging. So I need to go to this x and that y and plug in and see if it's equal to negative 9. So here we go. Is 3 minus 3 times y equal to negative 9? So again, check it out. X and y right here. And I'm plugging this x right here. That's where I got this. I'm plugging this y right here, which is where I got this. So is 3 minus 3 times 4, which is 12, equal to negative 9? And yes, it is. Let's do 2 checks. Remember, that worked for one line. We got to make sure we got both lines correct. So now I'm on this one right here. And I'm saying, is my 3 minus my 4, because that's x minus y, is that equal to negative 1? That was a quick check. Yes, it is. So this is definitely the solution to the line. So we've got 2 special solutions I want to talk about real quick. Now notice right here, our slopes are the same. That means these are going to be parallel. Let me show you what I mean. This first one starts down at negative 2, then goes down 1 over 1, like this. Now my other one starts at 0 on the origin, and it also goes down 1 over 1, down 1 over 1, down 1 over 1. And if you see, those are not going to hit each other, so they're not going to have any points of intersection, and they're not going to have any solutions in common. So there's no answer I could plug into this x and that x and get the same y out. Alright, last one here. I'm going to double check it. First thing we need to do is write that in slope-intercept form. So I need to subtract my 3x to the other side. So I have negative 4y equals negative 3x plus 12. Then divide everything by that negative 4. So if that first one was the infinite solution, or sorry, the no solution, then this one must be the infinite solution. So y is equal to positive 3/4 x minus 3. Oh look, that's the same thing I had for that other line. So while this one had no intersections, so no solution, this one's going to have infinite solution because we're going to graph one right over top of the other one. So let's take a look at that. If I graph my first one down at negative 3, I've got to go up 3 over 4, up 3 over 4, and then I go and I graph my other one. It also starts here and goes here and goes here. So no matter where this line goes, I'm going to have these matching points all along it. So again, that is my infinite solution, or all real numbers.